In this video, we're going to finish section 1-5, the distributive property. A little bit shorter video today because it's just one simple part, but we need it to finish up how to work with the distributive property. So in part 2, there's some stuff we need to know. So one thing we need to know is what is a term? You heard me say this word before, but I don't know if you really knew what it meant. It's a number, a variable, or a product or quotient of numbers and variables. So 3x, 3. T divided by x. These are all different types of examples of a term. Then we have what we call like terms. These are the same variables with corresponding variables having the same power. Or I like to say having the same variable power. So they have to have the same variable and they have to have the same power on those variables. So here you can see we have 2x squared plus 6x plus 5. Each one has a combination of a variable and a number, so that would make them all separate terms. And the plus signs or the minus signs will separate terms. And then the last one, the next part, 3a squared plus 5a squared plus 2a. Notice 3a squared and 5a squared both have an a squared. That makes them like terms. And 2a doesn't have a square on the a, so it's not like the other one. So it's not a like term. Okay? We are leading to this because we can combine like terms. Okay, so equivalent expressions denote the same number. So 5n plus 7n and 12n. So that comes from what I was just saying, like terms. Like terms can be combined. If they're like terms, think of them as labels. 5 apples plus 7 apples equals 12 apples. But if they were not like terms, say 5 apples plus 7 oranges, you don't have 12 apple oranges. You don't put them together. It doesn't make sense. Okay? And then simplest form is equivalent expression having no like terms or parentheses. So in the last video you saw that I was always saying, well, there's nothing we can do. This is why, because they all had a different variable power. They didn't have any like terms. So we're going to practice that here for a little bit. Okay, so simplify 15x plus 18x. So when we combine like terms, all we do is we add the number in front. We call that the coefficient. So the number in front, 15 plus 18 is 33. And then we simply bring down the variable with it. We simply bring down the variable with it. Okay, just again, think of apples. If you have 5 apples plus 7 apples, you don't have 12 apples squared, you just have 12 apples. Okay. Okay, so the next one, 10n plus 3n squared plus 9n squared. So what I like to do when I have more than 2 terms is when I see like terms, I like to underline the ones that are common. That way I know which ones I'm putting together. So I have 10n by itself. It's not there, so it's just 10n. But then I have 3n squared plus 9n squared. Again, just add the number in front, the coefficient. 9 plus 3 is 12, and then bring the variable with it. Don't change it, bring it with when you combine like terms. Okay? All right, simplify each expression, same thing. So there's only 2 terms. Are they like terms? Yes, so I'm going to combine 6t minus 4t. If I have 6 t's and I'm subtracting 4 of them, I only have 2 t's left. So my answer is 2t. Okay, the next one I'm looking at, and I see more than 2, so I'm going to underline everything that's the same. I have a b squared, no other b squareds. Okay, so I'm going to change the color so you can see it. I have 13b. I don't have any other regular b's. Okay, so I'm going to move on, and then I have a 13. There's no regular, just numbers. So that means I can't do anything. So this one is actually already simplified. There's nothing we can do. We are done. Okay, so that's what we're looking at today in this lesson.